Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is a continuation of all of our hard work going through exponential functions. You should already know and have already gone through a brief review of exponential functions, discussed the types of growth rates that we have and decay rates that we have with the exponential functions, and should have been able to find equations of exponential functions giving points. Now, we're going to go ahead and use a very classic old school problem, which is compound interest. Compound interest starts in Algebra 1 and continues through Algebra 2, which is intermediate algebra, and shouldn't be repeated thereafter just because you've seen it so many times. But here we are, we're just going to repeat it one final time, only because it allows us to introduce a calculus concept. You already know this whole entire formula. The value of some initial investment, P naught, earning interest at a rate R, which is compounded n times per year for t years, is given by the formula, right? So that's a memorizable formula. There's no way you can get around that. Technically, the time need not be per year. Could be per, I don't know, decade or something like that. But that's a typical period with which we are concerned with these problems. All right, let's see if what we can do with these. Now, before we get into what we can do with these, there is some language that I'd like to add to our nomenclature so that we can deal with these on a more cognizant level. So we're going to define APR, right, annual percentage rates, the nominal rate, and effective rates, also called effective yields. So the annual percentage rate, or APR, of an account is also called the nominal rate. They mean the same thing. And it is the yearly interest rate earned by an investment account. That's it. So when you go to a bank and they say they'll give you 5% interest for investing your money there, that's an APR. The term nominal is used when the compounding occurs several times per year. Generally speaking, APR as well. So when they say, oh, the APR is 6%, it's 6% and it might be compounded 12 times a year, but it's 6% divided amongst 12 periods throughout the year. The effective interest rate is, or the effective yield, is the simple interest rate compounded only once per year that's required to match the return on an investment compounding more than once per year. Now that sounds confusing, so let me just give you a quick example. Suppose that you have $500 you're going to invest, and you're going to invest it at 7%. And the 7% you're going to invest it at is in an account that earns interest monthly, compounds monthly. So it splits that 7% into 12 different segments, smaller segments, right? And then you're going to invest that for a full year. So every month for a full year, actually I can just put a number 1 at the end of that instead of the T, because you're investing for just 1 year. But for every month over the full year, you get a little bit of interest on that. Now, if you go to a calculator here, and in fact, maybe I should, we could always type in 500, except it's 500, times, 1 plus 0.07 over 12, and then we'll raise that to the 12th power. So we just get that compounding interest per month for 12 months. We end up with $36, and what is that? 14 cents. It's a bank. They're not going to round up for you. They'll just, they truncate. So they're going to not round up. They'll give you 14 cents. So you have $536.14. Great. Now the real question is, what rate would I have to invest at to get to that same amount if I did not get any compounding throughout the year? So again, I want to know if I have $500 and I invest 1 plus R for a single year. Okay. That's simple interest right there. I have my if you distribute this through, you'd get your $500 back plus some percentage of $500. And you want that to be $536.14. We just want to know, what is that simple interest R? We call it simple because it compounds only once throughout the entire year. So subtract 500 from both sides. I'm just going to block this off here. Subtract 500 from both sides. You have R times 500 is equal to 3614. And then divide both sides by 500. And you'll get R is equal to 3614 over 500. And I just grabbed a handy dandy calculator here. This is roughly 0.07228. It's actually not roughly, it's exactly. So exactly that, which means R would have to equal 7.228%. So if I had an annual percentage rate on my account of 7% and it compounded 12 times per year, I would get $536.14 at the end of that year. However, if you could not get, you went to a bank and they said, sorry, we're not going to give you an investment that compounds monthly, then you have to ask, to get to my same amount, you have to ask for a higher rate. You need a 7.228% versus my 7%, because yours is only going to compound once. Mine gets to compound and place interest upon interest throughout the year. So in simple interest world, you have to have a higher percentage to be able to match what I get with my compound interest world. So this simple interest one is called the effective yield. And it just lets us know, what would we have to have invested at to match this if it was simple interest? So you'll hear that in the world when you go to actually buy a car. It's like, oh, the APR, annual percentage rate, is 7%. And then they'll say, but the APY is 7.228. That's the annual percentage yield. And that's the difference between the two. APY is the simple interest compounding once. APR is compounding monthly. So let's do this again, but an official example, because I just kind of made one up on the spot. The effective rate on a $300 investment earning 5%, what is the effective rate on a $300 investment earning 5% compounding quarterly? So we have $300 earning 5% compounding 4 times per year. And we're going to run that for just a single year. You don't have to run it for 20 years or anything like that. It's just a single year is all you need to do this with. And you want to know what number that is. And you want that same amount to be what you would have received had you invested $300 at some other unknown rate. So these two you want to match up. The first thing I'm going to do is just, actually, if you set them equal to each other, since that's really what we're doing, right? You could technically compute all of this and write it in this middle area, but that's kind of silly. In reality, it's a little bit easier just to say, you know what, since these two will be equal to each other, we want them equal to each other, I'll go ahead and just grab this guy right here, move him over a little bit, and I'll solve. Divide both sides by 300. So let me just mark that in there. I'm going to divide both sides by 300 so that you have 1 plus 0.05 over 4. I'm not going to grab a calculator yet. I'll wait until we get to the end. And then, simple enough, subtract 1. It's actually not too crazy to do it this way, right? 1 plus 0.05 over 4 raised to the 4th. And we're going to subtract 1. And that should be our effective rate. So let's go ahead and compute that very quickly. So we had, let's see, it was a quantity 1 plus 0.05 over 4. And we're going to raise that to the 4th power. And then from that, subtract 1. And you can see that effective rate was 5 point, well, I'm going to write it this way. It's roughly 0.05095. I'm just going to carry it out that many digits. Let's go ahead and see what that looks like. So our effective rate is this number right here, which is roughly 5.095%. So I'd have to have a higher percentage rate because my investment does not compound quarterly. So I'm not earning interest on interest. Compounding allows you to earn interest on interest, but simple compounding or simple interest does not. It just gives you interest at the end of the year and that's it. All right, that does it for this video. In the next video, you can expect us to go into the natural base. And the natural base is where it's at when you start into STEM fields. You need to work with the natural base almost exclusively. There is one field within the STEM fields that does not use natural base exclusively, and that would be engineering. They use base 10.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.